Hey guys, I have your notes for 1-6 day 2 pulled up, and a couple of reminders here on the front. I just gave you a reminder about the order in which you need to list your transformations. So if I give you an equation and say list your transformations, and you say, okay, this has been done, this has been done, this has been done, this is the order in which you have to tell me. So you have to somehow remember, think pink, ladies first, or remember the acronym. Horizontal transformations are always listed first when you're talking about them, and we're always going to look from left to right. So we're going to look in the pink, left to right, and then we're going to look in the blue, left to right. Now on the very back of your notes, I have several functions that I want to point out. So we start off with the basic parabola y equals x squared, and then here's what a transformed parabola might look like, and it's crazy transformed. I got all 6 types of transformations going on. So what I want to point out to you is you got 2 sets of parentheses here, and I know you typically tend to look inside the parentheses for what to color pink, for which ones are going to be horizontal. And you're like, oh no, I've got 2 sets of parentheses. Well, it's the set of parentheses that's being whatevered. So in this case, since my parent graph was x squared, it's the set of parentheses that's being squared. Everything in here needs to be colored pink. Same way with the cubic. Oh no, I've got 2 sets of parentheses. Which one do I? Well, it's what's being cubed. That's what you look inside for to color pink. Absolute values. Now you don't have any parentheses. No, false. You do have a set of parentheses. But what do you color pink? Everything on the inside of your absolute value. Everything on the inside. And then, ooh, this one's going to be tricky. Reciprocal function is the trickiest of all of them. So keep in mind that your parent function looks like this. It's 1 over x. And remember, there's usually just an x in our parent function. It's being rooted or absolute valued or cubed or whatever. And this time it's 1 over x. So anything here with the x, anything here in this location with the x, that's going to be horizontal. Should kind of make sense. Plus 7, I think you know that would be vertical, so I would color that blue. But what do you do about this? Is it with it? Is it not with it? Well, I'm pretty sure most of you know enough about fractions to know that this -2, it's the numerator. I can pull the numerator off of the fraction and it still be the same. Right? If I take -2 times this fraction, wouldn't it equal -2 over? So same concept, I can pull it off, and if I pull it off to the front, it makes it way more obvious that it should be colored blue. All right, now, if I were to start talking about transformations, and here's another way that horizontal transformations get tricky. I read from left to right. Notice that there's an extra set of parentheses. These are kind of important. So here's what I would say. Ready? Starting with the left. I see a negative. I see this. I see this. Here I go. Horizontal flip. So horizontal flip. Flip over the y-axis. Tricky. Horizontal. Stretch of 2. Horizontal shift. Left 1. Let's do another one real quick. Horizontal flip. Flip over the y-axis. Horizontal compression of 1/2. Right 3/4. Now, keep in mind this pink that you're looking at, both of these are in factored form. And what I mean by that is the -1/2 has been pulled out of the parentheses. I could distribute it in. Don't. but watch. Just watch me. Isn't that the same exact thing? So the negative 2 on the outside stayed the same. I distributed my negative 1/2 to the x. I distributed my negative 1/2 to the 1. It's still being squared, and it's still a -3. It is the exact same thing. But listen to what I would say about transformations in this form. I would go, flip over the y-axis, okay? Horizontal stretch of 2, okay? Down 1/2. Oh, no. That's wrong. That is not what happened in this parabola. I guarantee you, this parabola was flipped over the x-axis, horizontal stretch of 2, and it was moved, I don't know what I said there, but it was moved left 1. This looks like it's been moved right 1/2, and it's wrong. How come it's wrong? Because it's not in factored form. So here's another rule that you're going to have to remember. You cannot talk about horizontal transformations if this is not in factored form. So if there's anything, if the x has a coefficient on it, you have to pull the coefficient off of the x before you can even begin to talk about transformations. This one is good. It's already factored. This one is good. It's already factored. So the -6 is pulled off of the x. It's perfect. That's the way it's supposed to be. Flip, horizontal compression of a 6th, left 1. Good. See this pink? You see how the x has a 4 attached to it, and then there's also a +2? Here's what you can't do. You can't tell me there's been a horizontal compression of a 4th and it went left 2. No, it didn't. Watch. Let me pull that 4 off. Same. Okay? Let me pull the 4 off. All right? I pull the 4 off the x. Here's what it looks like. Plus, divide the 2 by 4. What do you get? Now, it's all still pink. When I pulled the 4 off the x, I didn't do anything crazy, like put it out here with the, it's not going to change colors. It's not going to change from pink to blue. The blue stays exactly the same. The pink just gets factored, and it stays pink. Now, here are the correct transformations. Hopefully I can say this right. Horizontal compression of 1/4. It went left 1/2. Not left 2. So before you start listing the transformations, make sure the stuff in pink is factored. If you've got both types of transformations going on, you need to pull that coefficient off. Okay, going to the front, the page 1. I'm going to do the one down here first. So I would color this pink. They already pulled the numerator off for us. Wasn't that nice? And blue. Nothing needs to be factored. There's no coefficient on the x. So I'm gonna start talking about this. Ladies first. And then I'm gonna go blue. Moving on. Again, if I'm going too fast, pause it, copy down, catch up. I'm going to take this f of x is my basic cubic. I'm going to make a new function, so I gave it a new name. I'm going to make a new function by doing this, this, and this to it. Here I go. 5 to the left. Okay, that's inside. That's inside. 5 to the left. There we go. That's what 5 to the left should look like. And then reflect it over the x-axis. X-axis, that's vertical. And up 4. There you go. Next one, we've got absolute value. Oh, dang. I'll do the pink first. It says reflect it over the y-axis. So a reflection is going to need a negative symbol. Stretch it vertically by 4. That goes out in the front and down 2. Stretch by 4, down 2. Last one. It's a root function. You know what? I think I'll do the vertical first. Down 4. Whew. That's the easy part. Now, I need to stretch it horizontally by 5 and 2 to the right. Horizontally by 5. That is incorrect. That is incorrect. Because if I factored that, see the pink? If I factored it, here's what it would look like. This is what it's supposed to look like, but this does not match the pink words. So, to get what is written in here to match the words, here's what I got to do. Stretch horizontally by 5. I'm writing it already in factored form, and this is good. Because, no, it's not. Thank you for catching that. Because the horizontal transformations have to go and mess everything up. It's all backwards. So 2 to the right, 2 to the right. I got that. I got the whole backwards part on that. Stretch it horizontally by 5. Looks like that. Whoa, my bad. Backwards from what you would think. Kind of looks like a horizontal compression of 1/5, but you know that's backwards. Turn it upside down. That's a horizontal stretch by 5. That's 2 to the right, that's down 4, and this is already in factored form. The factored form has to match the wording. Okay, and then, so here's another good one that has us looking at factored form. It's telling me, talk about the transformations. I can do that. I can talk about the transformations, okay? So just kind of identified some stuff. Got my root, kind of darkened it so you know what's inside. All the pink is inside. This is outside. This is going to be so easy. This is so not going to be easy. Right now, it looks like we've got a flip, a compression, and a shift. But I can tell you that there's a lot going on in here. There's not been a shift of 6. There hasn't. How do I know? Because this is not in factored form. So it says, first we've got to change it so that it's factored. So the 5 is going to stay a 5. It is still blue. Everything in here is going to stay pink. I just need to pull the -2 off of the x. Don't make the -2 blue. Just pull it off of the x. It's still under the root. See? Still under the root. Just make your own set of parentheses. Make your own set of parentheses. So pull the -2 off of the x. Here's what's left. Divide out a -2 from +6. That's what you get. So now let's talk about what happened. Let's talk about the transformations. Pink first. We're going to look at the pink. It's in factored form. Let's start with the left and work our way right. Ready? Negative, all by itself. What does it do? Horizontal. So that's going to be flip over y-axis. Number 2, what's the next thing you encounter? A 2. That's a horizontal compression, 1/2. Horizontal compression of 1/2. And then, okay, check. This is what's left. Right 3. See? Told you there wasn't a shift of 6. It's got to be in factored form. And then the last transformation, number 4, is going to be a vertical stretch of 5. Okay, now, what takes place down here is just some real simple transformations. Hey, what's it look like? What's it say? Identify the parent function. Yeah. So here's what I'm going to do. I'm going to call it by name, square root. That's what it looks like. And then what happened? Well, I think it went left 2. Left 2. Look good? Next one. It's quadratic. And what has happened? Well, I think 2 things happened. So this is what it normally looks like, right? So one thing that had to happen is there had to be a vertical flip go on to turn it upside down. Vertical flip. And that would have made it look like this, right? Vertical flip. But then, I think it also went up 5. So I think my new equation would be y equals, no pink, so vertical flip up 5. One is absolute value. Y equals absolute value of x. Okay, and normally the vertex is at the origin. So I think it went 1, 2, 3. I think it went right 3. And I think it went up 2. Here's the up 2. Right 3. There's the right 3. Oh, dang. Up 2. Right 3. Oh, this one's tricky. This is a cubic. Now, normally the cubic passes through the origin. Again, I said these were basic transformations. We're not going to like do stretching or anything like that on these simple ones. Just how the vertex get from here to here? How did the vertex get from the origin to here? Well, I think it went right 1. And I think it went down 2. Y equals right 1 down 2. Okay, now this one is this one's a little more complicated. This one does have a stretch going on, and the reason I know, it starts at the origin and it does this, kind of like our root function. So the parent is the square root. And do you agree that normally this normal equation would pass through 1, 1? That's normally on my parent function. Look what's on here. On this one, I've got a point of 1, 8. What could transform a point that normally passes through 1, 1 to 1, 8? You might think, oh, up 7. It's possible. Did our root function get shifted up 7? No, because it still starts at the origin. Okay, scratch that idea. What's another way to turn this 1 into this 8? Multiply the y by 8. Do a vertical stretch of 8. That's what's taking place here. A vertical stretch of 8. And here's what that looks like when I write the equation. A vertical stretch of 8. Okay, that gets us through all the notes. That just about covers it. Make sure you remember that order, because that order is going to probably be worth some significant points on a test.